Okay, here we go. Ready? What is the limit as x approaches 1 from the right? Look at it. Yeah, that's why one of them says A on it. That's my goal. But the other homework 7's not due, remember? Okay, so the limit from the left, or the right, I cover up the left side. The height is how many boxes? 2. What about the limit from the left? Cover it up. What is it? 4. Okay, what about x approaching 1? D and E, because why?
They don't match.
They don't match. Very good. Okay, now notice the little prime. Remember, the prime here means slope. Okay, that's what we covered yesterday. So at -1, that'd be here. You're going to draw in a tangent line. It doesn't have to be perfect, and you're going to estimate the slope. So if I draw it in kind of like that, okay, what could be my slope? You're just estimating. -1/2 maybe? Okay, about. We'll make this an approximately 1/2. You would just be counting the slope of that point. So it looks like it's about 1/2. Okay, what about at -1.5? Okay, well, 1.5 would be here at the top. What's the slope at the top? 0. Very good. Okay, what about at 1? Come over here to 1. I look at my graph. I have a break in the graph. What's the slope of the tangent line at a break? Okay, because why? You can't draw a tangent line if it's not connected, right? So, because no tangent on a jump. Okay, hopefully you know what that means. Okay, next one, f prime of 3. Go to 3 on the graph. Okay, so 1, 2, 3 is here. What's the slope? 0. Go to 6. What's the slope at 6? So this is 1, 2, 3, 4, 5, 6 here. Count the slope of that line. Use the ends, rise over run. 3 over 2. Very good, because I'd have to go up 1, 2, 3 over 2. Okay, now what about at 7? 7's here. That's a cusp or corner. Which one?
Corner.
That's a corner because both sides are straight. That means your limit is D and E. And then I'll put because corner. Okay, but remember cusp would have been the same. Okay, last one, f prime of 8. 8 scooches me over to this side of the line. Instead of a positive 3 over 2, that side is negative 3 over 2. Easy? Okay, go down, skip for me to the bottom question where you're using the definition. Let's see if we remember it. Okay, 3A, it says estimate the slope of the line using the definition. So here's the definition. I want f prime of 6. F prime of 6 equals the limit. What should x be approaching? 6. And then remember, I do f of x minus f of 6 over x minus 6. That should look familiar. That's what we covered yesterday. What is f of x? 2x plus 4. And how am I going to find f of 6? Plug it in, right? So f of x is 2x plus 4. Limit still x approach 6. Minus, and then f of 6 I'm going to find right here. So that'd be 2 times 6 plus 4. 2 times 6 is 12. 12 plus 4 is 16 over x minus 6. Okay, from there, we're going to work out the limit. We've got choices. We can do factor cancel or L'Hopital's rule. I'm going to pick factor cancel just because it's easier, but L'Hopital's rule would work too. Okay, combine the top here. What is 4 minus 16? Okay, so I have x approaching 2, 2x minus 12 over x minus 6. How can we fix it? Factor out a what on top?
X minus 6.
Yeah, when I take the 2 out, it's an x minus 6. And then I have 1 on top and 1 on bottom. What can I do then? Cross these guys out. What's the answer? 2. Now, we're going to do it the short way. If I asked you to find f prime of 6, you would just take the derivative and then plug in 6. What's the derivative of that? 2. Did you get the same answer? Yes, then you know you did it right. One's a little bit longer, but the derivative rules are your shortcut. Okay, that get you straight to the answer to where you know what you should get using the definition. Okay, we're going to do one more off the back, please. Turn the page. Okay, look at the top one. Set up your definition using your limits. Am I good to turn it?
Yeah.
Yeah?
Yeah.
Great. Okay, so look at it. Limit x approaching what value? 5 of f of x minus f of 5 over x minus 5. Okay, from there, we're going to find f of x, find f of 5, sub those values in. Now, f of x was given to you, boom, right here. F of 5, I'm just going to plug that number in. So if I want f of 5, that'd be negative 5 squared plus 4. What's 5 squared? Okay, 25, so it's negative 25 plus 4, which is negative 21. Good. And then I'm going to take that value, I'm going to sub it in here. So now I know f of x, I know f of 5, I can use my limit. So limit x is still approaching 5 of f of x, which is negative x squared plus 4, minus negative 21. Now, what do you know about a double negative? Yeah, they cancel out really to just be a plus, right? So I have the limit x approach 5 of negative x squared, and then I have a plus 4 and a plus 21, 25. Now, remember, we have a lot of different limit strategies. You could do L'Hopital's rule, because you get 0 on top and on bottom. But I can also fix that to make it factorable. How could I fix it? Take out a negative. So watch, I'm going to factor out of the top a minus 1, and then what's left over? My x squared is now positive, my 25 is now negative. And then this guy, you can break it up into a plus 5 and a minus 5. So I have negative 1 x plus 5, x minus 5. Now, what was the point of that? Good. So that I can cross out those minus 5s and then plug in what x is approaching, which is also 5. So these are gone. 5 gets plugged in. What's 5 plus 5 in the middle? Negative 10. Now let's use it using the derivative rules the easy way. Look at your function. It was a negative x squared plus 4. What's the derivative of that? Okay, but when the 2 comes down, now it's a negative 2, right? So negative 2x. What about the plus 4?
0.
Goes away. Then what do I do with 5? Plug it in. Negative 2 times 5 is negative 10. Okay? So you should understand that the derivative rules that you've learned are all shortcuts for long algebraic things that you don't really have to do on the AP test very often, but you have to recognize them. So there's one more limit definition we're going to take notes on, and then we're done with all this algebra. Okay, so open your notebook. Okay, and these are going to show you how to do the last 6 on your homework that's due today. Yeah, so we're going to do the last 6 on that before you turn it in. Okay? All right, so at the top for me, please. We're going to write down 2 definitions of a derivative. One you already know. It's the one that we just did. F prime of A equals the limit x approach A, f of x minus f of A over x minus A. Okay, check. We already learned that one. That's the rule that you need to know, number 1. Now, I'm going to try to very briefly re-explain where that comes from, because our other definition comes basically from the same thing. So, sketch a picture for me of a graph. Okay, we'll say it looks like that. And then I want you to draw the tangent line at whatever we're going to call A. So I'm going to put my A right here. Okay, so let's just remember what this definition is. If I cover up the limit, what's that? What's that the formula for? Slope. y2 minus y1 over x2 minus x1. So this right here, this is just slope. So I'm going to put my x point way over here, and I'm going to draw the slope between those points. So if I move my x to over here, how good of a prediction is that secant line for the actual slope that I want right here? Is that close to the slope of f prime? No. So I'm going to move that point closer, right? I'm going to move it maybe to where x is here now. Did it get a little bit closer to the real slope of the line? Okay, then I move it in one more. Will you grab your test out of that stack right there, please? Okay, and then what happens as that point gets closer? My secant slope gets closer and closer to my tangent slope, right? Okay, so that's where the limit comes from. So it's the slope of 2 points. Slope of 2 points. And then the limit part of this tells me that the points get closer and closer together. Okay, and as you do that, it's going to approach the slope of the tangent line. You can just pick a seat in here. Okay? So the other definition is written a little bit differently, but it's kind of basically the same thing. So here's the other definition. This is number 2. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over x plus h minus x. Okay, so write it down first.
Can I keep this in your fridge?
That is not going to, you might have like a baby size fridge.
I promise.
Okay, go for it. Okay, so what's the first thing you notice about this? What does that look like, the formula of? Slope. It's still slope. Now, what are my 2 points? X and x plus h, right? So we're going to redraw our graph here. Okay, this time put your x, we'll say right here. What would x plus h be? Well, it would just be x plus, we'll say maybe h is this long. Well, then that puts x plus h right here. That just gives you a second point. So far, so good? So I still have 2 points. I'm still taking the slope between them. But what is going to happen as my h, which is how far apart these are, as that h goes to 0, what's going to happen to this second point? It's going to do what? It's going to get closer, just like the other limit. When h, which is the distance between the dots, goes to 0, that second dot is coming closer and closer. It's the same thing, it's just written differently. Okay? So we're going to do a couple of examples, I think only 3, and then we'll do your homework. So number 1, find f prime of x using the definition for f of x equals x squared plus, oh, nothing, just x squared. Actually, yeah, we'll do plus 4. Bless you. Okay, so first thing I want you to do is write the definition, which is right here. Now, can I point something out to you on the bottom? What's going to cross out? The x's. So when I write my definition, I'm not going to put those x's there because they just cross out anyway. You can put them if you want to, but not necessary. Okay, so I have limit h approach 0, f of x plus h minus f of x over h. Notice I'm intentionally dropping the x's off the bottom because I already know that they're going to cross out with each other. Okay, now we're going to have to sub some stuff in. So f of x is right here. How would I find f of x plus h? What would I do to my equation? Instead of an x squared, now it's an x plus h squared. Are we good with that? Okay, if it's f of x is this, then f of x plus h, I'm just putting a little plus h in where my x was. And now I'm going to expand this out. Now, did y'all learn the expansion for this? The little shortcut, or no? No? Okay. So then we'll times it out. So let's do x plus h times x plus h again, plus 4. What's x times x? X squared. What's x times h? xh. Next I'm going to do h times x. What's that? Same thing. And then h times h. H squared plus 4. Now the shortcut is that if you ever want to square something, just list the first term squared plus and then double the middle term. So if it's xh and xh, I know in my head that's going to be a 2xh. And then plus h squared plus 4. Okay, so here's what's going to happen. We're going to replace f of x plus h with this. We're going to replace regular f of x with this. So we're subbing our definition for like equations instead of function names. So limit h approach 0, stays in the front. X plus h is this. X squared plus 2xh plus h squared plus 4 minus x squared plus 4 all over h. So this is my f of x plus h. This is my regular f of x. What do you notice is going to cross out? Two things. X squared, 4, 4. Now everybody left has what letter in them? An h. So I'm going to GCF my h out to the front. What's going to be left over from the top? The h is gone, so that's just 2x. And then out of my h squared, what's left? Just an h over h. Now, why is that better? What can happen now? Cross out the h's, because remember, I can't plug in h approaching 0 if there's an h on the bottom. Now there's not. So plug your 0 in. What do you get? Okay, now, what's the derivative of x squared plus 4? It's the same thing, 2x, yeah? What's the derivative of this? 2x. What answer do we get after all that crap? 2x. So this is the long way that the derivative rules were discovered. Yes? Yep, all that.
Why do you do all that?
Okay, so I'm going to show you on the AP test how they test it. We're going to do 3 examples total. So you've done 1, you got 2 more, okay? Good? Huh?
Leave it at 2x?
So, yeah, and now look here. I'll do it here by rules. Okay, if f of x is x squared plus... You don't have to write it if you don't want to. It's okay. Then f prime would be what? 2x. So these should still come out the same. Whether you do it the long way or the short way, your answers should match. Yeah. No, it was only a half a page. Come on. Okay, so I'm going to answer all your questions in due time, Ebenezer, okay? I'll show you. All right, may I turn the page? Good? Here I go, turning the page. Nope. Yes? Okay. All right, so the next one is a little bit longer, but the third one is shorter. Okay, so the next example, we're going to take the derivative of 3x cubed. 3x cubed.
Is it number 3 or number 2 or what?
This is number 2. Oh, I did say the wrong thing.
Before you're like 2, 1.
Yeah. Okay, ready? And then if you want to write using the definition, you can put that on there, okay? Now, let's real quick, what should the answer be if I do my rules? Okay, so I'm going to put here, the answer I know I'm going to get, 3 times 3 is 9, x is squared. If I don't get that, I messed it up, right? Okay, so here we go. Limit h approach 0, f of x plus h minus f of x over h. Now, f of x I already know. That's what they had to give me. That's my equation. So here's f of x. What will f of x plus h be? Three x plus h cubed, right? I just take my x, I'm giving it a little plus h to go into the equation with it. Okay, now the only reason that this one takes a while, okay, is that we have to expand this out, okay, but it'll only take less than 2 minutes, okay? So the first thing I'm going to do is I'm going to group them into 2's. So I'm going to do 2x plus h, I'm sorry, 3x plus h, and then x plus h squared. Now, you just put it back. Thank you. Look at it. Is that the same? Are those the same, line 1 and line 2? Yes. Okay, so what I'm going to do is I'm going to group these two together. I'm going to group these two together, and I'm going to use my shortcut. So 3 times x is 3x. 3 plus h is 3h. And then here, I'm going to expand this out using the shortcut I just taught you. So remember, it's the first one squared plus double the combo, so 2xh, and then plus the last one squared, which is h squared. Now, you should have learned that shortcut in Algebra 2, but if not, you could just expand it out yourself, okay? So here we go. We're double distributing. What is 3x times x squared? 3x cubed. What is 3x times 2xh? Okay, 6. X is now squared with only one h. Okay, next term. Last one for my first thing I'm distributing. 3x times h squared is 3xh squared. So far, so good? So I distributed the 3x. Now what are we distributing?
3h.
3h. Good. What's 3h times x squared?
3hx squared. 3x squared h.
Good. Okay, 3h times 2xh. 3 times 2 is 6. Xh squared. Last one? 3h cubed. Yeah? Okay, now let's review what we're doing. All of this is my x plus h. This is my f of x. I'm going to subtract them on the top. What am I going to put it over? An h. Here we go. So, okay, this is the longest one we're doing. Okay, and then we're almost done. So, 3x cubed, 6x squared h, 3xh squared, 3x squared h, 6xh squared, 3h cubed, minus 3x cubed. Yes, you can. Okay, now if you looked at it, kind of imagining I'm subtracting, which terms are for sure going to cancel out?
3x cubed.
The 3x cubes. What do you notice about everybody else left over?
They all have an h.
They all have an h. What am I going to do with that h? Pull it out to the front and do what with the h on the bottom? Remove it. Very good. So I'm going to have the limit as h approaches 0. My h is in the front. What is left over from this term? I had a 6x squared h. I took out an h though, so it'd still be a x squared, right? Okay, now look at your next guy. He's got to lose an h. How many is he going to have left? 1. A 3xh, because his h was squared. I pulled one h, I have to leave the other one. Okay, next term here. 3x squared h, I take the h out, what's left? 3x squared. Okay, next guy here. He loses an h. What's left over?
6x
And then last one?
3h squared.
Okay, good. Then I have my h on the bottom. These guys cross out. And what was h approaching now that I don't have a denominator? 0. So I'm putting a 0 everywhere that I see an h. So I'm putting a 0 here. What happens to my 3x? Gone. I plug in a 0 here. What happens to my 6x? I plug in a 0 here. What happens to my 3h squared? Gone. What are the only two terms left? 6x squared and 3x squared. What did they add to?
Bro, this is so hard.
No, don't be done. Only one more, Ebenezer. You barely got in our class. You can't quit already.
You're not. Stop trying to be like me.
Got it? I will, sure.
So we don't have to do the long way?
Okay, correct. Correct. Okay, I have one more for you. Just one more. You ready?
Wait, why is it upside down?
Your sister knows what's it.
Your shirt.
Oh, autism seen from different angles. Get it? Alright, last one. Okay, come on, one more. You can, I'll bring you like Chips Ahoy on Monday, okay? I promise. Chips Ahoy. Okay, last one. We gotta go or we're not gonna have time to finish your homework. Okay, so write down your limit. Last one. F prime of x equals the limit as h approaches 0. Focus. Okay, look at it. F of x is root x. What will f of x plus h be? All you're doing is you're letting x sneak a little roommate in. So now it's root x plus h together. Okay, focus. Okay, so here we go. I already have my f of x and my f of x plus h. I'm ready to put them in my formula. So I'm going to have the limit as h approaches 0 of root x plus h minus root x over h. Look good so far?
Yes.
How do you fix radicals? Factor cancel's not going to work. Starts with a C.
Cancels.
Nope. Con. Jug.
Conjugation.
Conjugate. Okay, we're going to use the conjugate. So if I have root x plus h minus root x, what's the conjugate of that? Okay, focus. Okay, so when I multiply by the conjugate, I have to do it on top and on bottom. Do I ever times out the part where they're not conjugates? No. So I'm going to leave the bottom separate, but I'm going to times out the tops. So here we go. We're going to not write the terms that cross out. So what is root x plus h times root x plus h? X plus h only, because remember, the square root becomes squared and then crosses out. Okay, now my next two terms cross out, so I'm not going to write them. I'd have a root x plus h times root x, and then a minus of the same thing. Those guys are gone. Last term, what's root x times root x? Minus x. Good. Yes? Sure. Okay, remember my limit was h approaching 0. And then on the bottom, I also have the leftover conjugate. My top one fixed a lot of stuff, but my bottom one I just kind of leave there out of the way. Then what happens on top? Okay, the x's cross out, and then what crosses out? The h's can cross out, and then all that I'm left with is the limit as h approaches 0 of 1 over root x plus h plus root x. Now, if h is approaching 0, I'm going to plug in a 0 here. What is x plus 0, though, still? Root x plus root x. And what is root x plus root x? 2 root x. Okay, that's the answer. Now we're going to do it via derivative rules. Okay, so fun. This is my favorite lesson all here. Just kidding, it's not. Okay, so let's say that your equation is root x. How can I rewrite that so it's a power? 1/2, very good. So I would have x to the 1/2. Now I'm ready to take the derivative. What do I do with the half? I times it down to the front. And then I have to take away 1 from a half. What's a half minus 1? Negative a half. And then where would my square root go if the half is negative? To the bottom. What? What? The same? I will show you what it looks like on the AP test. It's way easier. You're going to love it. You're going to love it. Okay, so ready? You want to know how it is on the AP test? Turn to homework 6. These guys right here. Okay, you're looking at the bottom of homework 6. We're going to finish it in 4 minutes. Now you're thinking, wait, those other problems took 10 minutes. Okay, here's why. Okay, this is homework 6. On the AP test, they're going to give you, Ebenezer, okay, they're going to give you a limit like this. All that you have to do is know where the f of x is. So look at number 16. If that's my limit, I know that's the definition of a derivative. Where is f of x in the definition? The 6x cubed. What's the derivative of 6x cubed? You're done. Okay? Now, could you do it the long way for fun? Yes, you could. And no, do it. No, just kidding. Okay, now look at 17. Circle the function. It's only the sine x. What's the derivative of sine x? Okay, now, quick question. Then let's talk about the negative. Okay, the negative is part of the derivative formula. Yeah? So, like, look, can I show you? This negative is built in. So, when you circle the function, you need to not circle the negative. Okay? So, look at the last one on the top row. X squared, what's the derivative? 2x. Okay, go down to 18. See, I told you you'd love it. You would have taken it for granted if I hadn't made you do it the long way. Okay, 4 ln x. What's the derivative of ln x?
1 over x.
1 over x. Now, could I combine that into 4 over x? Sure. So if you like that better, I like that better. Okay, but the derivative of ln x is 1 over x, then you just times it by 4. Okay, next one, circle the function. What's the function? What's the derivative of 2 cosine? Negative 2 sine x. Good. And then last one, 2e to the x. What's the derivative of that? You're done. Great. Alright, so your homework 6 is due now. As long as I have it today, I will not count it late. So if you have a couple you need to finish up, you can do it and give it to me after school. I'll be here till 4:30. Well, you pass it up, yeah. Or just put it on the table on the way out. It's fine if you don't want to get up. Oh, y'all did great.